Yeah, hi, good evening, folks. So much for joining on time. Just wait for 2 minutes and then we'll give it to go. All right, folks, I believe we will be giving it a go now. Let me please share my screen. All right, so just a quick confirmation that you all can see my screen and you can hear me pretty well.
Yeah, we can hear you.
All right, full information. All right, so yesterday we started with business analysis. Business analysis as a generalized concept. And then we started with what are the different specific techniques we have up in here. And in those techniques, we started with, wait, presentation by frozen. Yeah, let me just restart my presentation. Looks like it's not going out. Okay, going well now. All right. So we talked about the business analysis framework yesterday, wherein we saw that there are multiple of these steps in it. And then we jumped onto the business analysis framework techniques. First technique was SWOT that we discussed yesterday, which was all about coming up with these strengths and weaknesses as the internal factors and opportunities and threats being the external factors. Now, the next one is most analysis. Most, as the name suggests, it's more like an acronym for mission, objective, strategy, and tactics, right? Now, when you say that you have a business analyst, right? We got these four elements. We have mission, which is the for a larger, or you can say larger mission.
Yeah, but the thing is that I am not able to do that in the end of the day.
Sorry, you got any questions? Okay. So thing is that when you're talking about the mission, it's going to be a larger mission. Like let's say you have an healthcare organization, and that organization says that we want to be in top 10 in US in like let's say 5 years or 10 years, then that's going to be the mission. Okay. But to achieve that mission, that organization needs to go with clear objectives, or you can say goals. Now, these goals needs to be smart, like time bound, actionable, measurable, right? That is what it should be. So, like, let's say right now that particular organization is at, let's say, 128th position. Now, from 128 to top 10 in 10 years. So they need to go with that. Okay, in first year, how much? Second year, where? Third year, what place? Fourth year, what place? So that way they need to those yearly objectives. And that would be breaking down into monthly objectives. Then we have strategy. So strategy is your action plan, like how those goals will be achieved, right? Strategy will be made at the leader level, and then they would share tactics by the people who are actually going to do the work. For them, it's going to be tactics. So that is how it is all. See, this may or may not be, relevant to your application development. It's primarily used for an organization where the organization is struggling to, to actually identify what's the purpose and the mission it has. This is important. This is BPM, business process modeling. Now, business process modeling, it is more like, see, it's modeling, right? So modeling, it's going to be some representation. Now, here we are talking about pictures. So this is going to be a graphical representation, which is like in the form of some pictures we'll draw. And with the help of that picture, we can have any specific workflow, and that business workflow will be having more clear understanding using this technique. It's a pretty much a legacy process, and it's been there for years now. And that's where we're going to learn this UML, which is Unified Modeling Language. I'll talk about that as well. Now we have IIBA, which is, you can see here, they have mentioned International Institute of Business Analysis. They said that, okay, in the business process modeling, You need to be having these like planning strategically, business model analysis, defining and designing business process, technical analysis for complex solutions in here. But especially in IT industry, this is like very much useful, right? Because it's all about creating pictures for the business processes. Okay. And a picture speaks more than 1,000 words. So that's where it is like super useful. Then we have something known as NFRA. Now, NFRA is what I'll tell you. See what happens now. This is non-functional requirement analysis. Now, so far, what we have seen here is that we were going with requirement analysis. Now they are saying that we have something known as non-functional requirement analysis. Now, because there is non-functional, there needs to be a functional as well. Right? So there's a functional requirement analysis as well. Now, what's the difference? What's the difference between these two? The thing here is that both of these are what the requirement analysis. Requirement analysis you do for what? For requirements. So basically, these two are dependent upon two different types of requirements. One is functional requirement, another one is non-functional requirement. Now, let's say that, okay, we are creating an application. In that application, because we discussed earlier that what we do, we create requirements. Or like you can say, we get requirements from client, analyze those requirements. And what we do in the software development process is we convert or we implement those requirements into features and functionalities in the application. That's what it is all about. And what is non-functional? I'll give you an example. See, let's say we have an application which is performing, let's say, arithmetic. Arithmetic operations. And there's a simple operation of, let's say, multiplication. Now what happens that, say you have this up in here, okay? So let's say in that application, you are asking the user to enter two numbers. Then you have a button. Result box. Okay. Now, what would happen here is that in this, the number, let's say the user is entering 5, 4. Simple. And the user is supposed to press this button. Now, what should be the result? 20. So if we put this up in this is like functional application. But if I put this as a requirement, then what would be the requirement? Like user will be providing two numbers as input. And the application would be calculating the multiplication of that number. Now, if we are getting the multiplication correct, which means the functional requirement is fulfilled. 5 multiplied by 4, we are getting 20. That is the functionality. So we got, if we have achieved this in the application, which means functional requirement is fulfilled. Okay, because that was the functional requirement that if the user is entering two numbers, he should be getting the result of the multiplication of those two numbers will be there. Now, what is non-functional here? Non-functional here is, let's say, now what could be the non-functional requirement? Let's say if it is taking 2 minutes to produce this output, like when you click onto this, there is no output. And like after 2 minutes, 120 seconds, you are getting the output is correct, but it is taking 2 minutes to produce that output. So even if it is taking 2 minutes, our functional requirement is fulfilled, right? But in this case also, will this solution be accepted by the client? No. They'll say that, okay, you're getting the correct output, functionality is working fine, but what about the performance? Application is producing the output, but 2 minutes, 120 seconds just to get you the result of 5 multiplied by 4. What's the point of having such application, even if it is going correct, even if it is giving you the correct answer, not giving on time, right? All right. This is performance. So the performance is not at par. And that is your non-functional requirement. Performance, which are not directly related to the functionality, but affects the acceptance of the application by the client. We have security, right? We have user interface requirements. These are all non-functional requirements. Security, now security they have included in core prime requirement nowadays. But even like when you talk about security, it's a non-functional requirement. Even if the security is not there, the application will perform, right? Security is all about making that application secure so that not anyone can misuse that particular application. That is non-functional requirement analysis. And this is also part of your BA's requirement analysis only. See, we have these: performance, security, logging, reliability. These are the non-functional requirements that we have up in here. Performance, I just showed you. Security will be there. Logging is like, whatever is happening in that application. It just creates a record of that. Every action performed by the user, they have it. And you have reliability as well. That's how it is. Now we have brainstorming. Brainstorming is what? It's a baseline technology. It's not something that would be on top, right? But it is used to support other business analysis techniques like SWOT and most, because brainstorming, as the name suggests, you will make people speak. Sometimes, people are there and you want to get things out of them, Like you want to speak, you want them to speak more and more so that, see, the more they'll tell you, more clarity you will have uh, about the client requirements. So you want them to open up, you want them to discuss things with you, and that's how it is. No, that's how it is. We go with this. Now see what happens now. When you have this as a baseline brainstorming, you can use that as a baseline technology in other words. Requirement analysis, we already know about it. Okay. Requirement analysis is all about what you do there in this. That's how it is. Now we have talked about the requirement analysis. Now in requirement analysis, if you want to do an effective requirement analysis, right? You need to go with these three: brainstorming, shadowing, and prototypes. Now, when you talk about brainstorming, I told you that already. Okay. Brainstorming is all about that bone technology, baseline technology. What is shadowing? Shadowing actually is shadowing, it's all about you actually kind of go with these your client, you kind of like over their shoulders, you analyze everything. Like let's say if you talk about very simple example of a library management system. Now, if you need to understand how the things are happening right now, right? Now what? You could see that up in here. Let's say like when a student walks in, right? How that student is looking for the books. What's the process there to search for the desired books? And then like that student goes to the librarian with that book. How librarian is issuing that book. Okay. That is all in here. That is all it goes with this whole process, understanding the whole process, right? That is what shadowing is all about. Prototypes. Prototypes actually to go ahead with this technique, you need to be very much in close collaboration with your what do you call as development team. Because in this actually we go with prototype when the client self is not having much idea about the application. So they just come with did they just come to you with, some basic requirement like one or two, and then they ask you to go ahead with that? Okay. And when you go in there, they would ask you that, okay, what are the requirements? They tell you like basic requirements. Okay. And then you go with those requirements to the development team. Development team creates specific what do you call as specific product or like a demo application around that. Okay. And then what happens? Then what happens is based on to that, they will create something and they'll share it with you. Okay. And once they share that with you, you showcase that to the client. By looking at that simple application, client actually will have more ideas about that. And then they will tell you that, okay, how this is all going to be, right? They would share that with you, and that's how it would be. And then again, based on to those inputs, it would be shared with these guys again, your development team. Okay. So that's how, like, and then like development team will further do some modifications. They'll show it's not the real application. It is just that it is just that what do you call as a demo kind of application, a prototype, not the final one. And then finally, when the client will say after so many of these iterations that show developing, showcasing to the client will tell that, okay, yeah, this is something that I wanted. Then they'll do like backtracking and then they will come up with the real requirements for that. That's how it is. So that is what the effective requirement are. Then we have GetWo. Now, this is actually more about the pain points of the customers using some questions. Right now, this CATWOE, some people call it as GetWo. In that, what happens now? It is an acronym. Say C stands for customers, actors, transformation, worldview, owner, and environmental constraints. So you got some questions in these, and those questions you have to ask while coming up with the requirements. This actually gives you more insights in terms of what actually you have here. Like if you talk about the customer, then who are the beneficiaries of the business? How does the issue as in like, let's say you are doing this analysis for a specific problem that your client is facing. Then using this technique, you will get like everything like in and out about that particular problem so that you'll have more clarity, more understanding towards the requirement, and you can propose a, a specific solution for the same, right? Actors who are actually involved in this situation. What is the transformation lying at the heart of the system? What's the big picture? How it is going to impact the overall like surroundings, area, city, country, world. What is that outer impact, right? Who's the owner of that impacted system? Are there any? It's not necessary that there would be always some environmental constraints, but if there are, right, then those needs to be mentioned. Now, let's say if, let's say in e-commerce, you might not have those, but let's say if it is an oil and gas organization, they are going with this. And see, these techniques may or may not be useful specifically um, for your project. These are like generic approaches. User stories you already know because we talked about Agile earlier. So user stories all about how user wants to tell you the issues, the problems up in there. So that is user stories. It's a way of sharing requirements by your client in Agile. So that is another technique. Then we have PESTEL analysis. PESTEL, again, an acronym wherein we're going with each of these like different environmental factors. Like P is political. So let's say there is a change in the government, right? And you are working with an healthcare client, let's say, and let's say the government, let's say the change in the government, or let's say the government has changed some healthcare policies like Medicare, Medicaid policies. So in that case, how it is going to affect your application? Because you have an application and that application has to adhere to those Medicare and Medicaid policies. So that's how it's going to be all up in here, political. Economic is all about going with the economic conditions in the country and how it is all happening there internationally. So you have interest rates, inflation, cost of labor, energy. These are those different factors which could not, irrespective of like, not everything would contribute into your application, but whatever it does, you need to take a note of that. Social. You cannot create same application for US and similar application for the people like in Asia or like in Asian countries, right? So depending upon the population, culture, education, media, lifestyle, you have to have that particular pin here. Technological, right? So what are the innovations, breakthroughs? I keep talking about AI, right? Because AI now everyone wants to get integrated into their application. So yes, so you also need to take care of that. Legal, if we have any, right? Businesses, work culture, employee welfare, environmental. What are the impact of businesses on the environment, like pollution, recycling, waste? All that would come under this PESTEL analysis. Similar stuff. So that is what these are, these different techniques that we have up in here. So we talked about these I'm not saying that you're going to use all of these in each of your project, but depending upon like what specific project you have, you can go ahead with that. Primarily, see, you would be using this. This will be there. This will be there. This is a baseline, so it will be behind other techniques. This anyway part of it. This anyway part of it. This is good to go ahead with. This depends if you want to analyze that specific issue or not. Most might not be there. So that's all like, see, you can decide. These are all business analysis framework techniques. Help you to have an effective requirement analysis in that particular term. Now we talk about UML. All right, UML is what? Unified Modeling Language. I'll not go into the history and all that because those things are like self-explanatory. But I'll tell you what UML actually is because we're going to work around this. we are going to learn that application software, which is implementing UML. Even when you talk about going with UML, which is Unified Modeling Language. Now, as the name suggests, it's going to be a language for modeling and it's unified across globally. Okay. Now, what you can do with this is actually you can create diagrams, which can help you to visualize the system or a specific process, not only in a static way, but a dynamic way as well. Right? And once that approach is finalized, we're going to get those exact setup diagrams. Right? Now, UML is not something which is used only by the BAs. It can be used by developers, designers, in automation and documentation. So for you as a BA, you're going to use that in analysis and documentation. Now it all started in 1970, and then 1996 they came up with the first version. The first version was 1.0, where these three technological giants, they kind of shake their hands together, and they joined their hands together and they came up with this IBM, Microsoft, and Oracle. And if someone asks you what is the latest version, that's 2.5, which came out in June 2015. But it is like there were no major updates after that. So what we use here is UML 2.5. Now in UML there are multiple diagrams because it's a unified modeling language. So there are different diagrams which are available there. So we have structural and behavioral diagrams. Structural are like more static in nature. We have class, object, component. I have a separate document where I'll show you this with the help of an example. So we have these diagrams, but these are all about stable systems. That's why these are static diagrams. So structural, static, synonymously used. These are different structural. Then we have behavioral, which are like you can say dynamic diagrams, right? So these are the moving aspects of the system, right? That's what it captures. So these are the dynamic diagrams that we have here in form of behavioral diagrams up in here. I'll talk about these in a separate document. Now, when you talk about some important diagrams, we'll create one of these as well in our session. We have first is use case diagram. Now, use case is what? Use case actually talks about, I'll tell you, in simple words, use case is all about who will be doing what in that system. Okay. So in that system, like who will be doing what? Like, let's say if we have this example here. Okay. So this is in simple ATM machine example, wherein if you go with that, you would see if we take this as a whole system, right? We kind of talk about this, right? So this is like the who part. We are going to call these as actors. They are the who in this. And this is your system. So what they are doing in that system. So that what part, we call it as use cases. These are the different use cases, like administrators doing the system maintenance, which includes system reporting and system shutdown. Bank customer is doing login and transactions like withdraw cash, check balance, deposit, uh, taking out the receipt, right? Transactions are all approved by the bank. Okay, if the user is entering wrong PIN while doing the transactions, can enter into a bad PIN scenario as well. So these are all like who is doing what. So these types of diagrams actually gives you a clarity. And that helps you to, come up with the requirements accordingly in a more effective way. So that is like use case diagram. We have data flow. Data flow is like pretty simple. It shows you the flow of data. This is primarily used by the programmers, right? When they need to know that, okay, which specific database. Now, see, in these diagrams, you would also mention a database. We'll talk about database later because we have a separate module wherein we'll learn how these like databases are actually used by the QAs in here. Goes up. That's how it all goes. So in that, you can see that this is the database that you have in here. And this database will have the patient information. So like these are different processes, okay? So with how the data will be flowing between these processes, that is what we have. That's how it is, okay? So like when find patient and which data to be moving between these different processes, that is what it is. Now we have ER diagram, which is like entity relationship diagram, right? In that, what actually they do is they go with these entity. This is actually for the database people using that. Actually, they create these like databases up in here. Okay, this is how it all goes up. Now, let's say there are multiple other diagrams as well. See, we have deployment diagram. These I'll actually show you in some other document. I have already shared this with you. Just give me one quick sec. I'll share that again and I'll share one more document which where I'll actually discuss these different pictures and diagrams with you. This is the one. I'm again sharing the presentation also in the chat, just in case if you would have missed it earlier. All right, I have shared both in the chat. Now I would take you to this diagram. See what we have in this diagram is this is more like an quick reference guide that I have prepared, wherein we talk about UML diagrams, primarily what you would be using there. So actually all the real world entities you have, these are actually defined in this as things. Okay. And these things could be like structural, behavioral, grouping, and annotational. And in those things, what you would have is when you talk about the structural, you have these like class. Now, what is class? Class basically, in this terminology, is more like a template. Right? Which is used to create objects. Because objects are the instance of these classes up in here. So class provides you that definition that what attributes that object will have and what would be the behavior of those objects. That is what it is defined in the class. We have an example here. Let's say we take an example of a car. Right? Now Ferrari, BMW, these are not classes. These are objects belonging to the car class. So it's like car is a class and it has like two objects. And both of these objects, you can see, will share the same attributes. Name, price, name, price. Value is different, but attribute is same. So all the objects belonging to the same class share that. Now they have some behavioral things up in here, right? That is fine. Package is all about, grouping these classes together. That is how it is. That is how it is. Okay. And what would you actually kind of go with that up in here is you will have these specific basics. I'll talk about each of these. Relationships are fine. This is association. This is not for you. See, this is a class diagram. Okay. Wherein it is showing you what a class. I told you that class will have attributes and behavior. Right? Attributes are basically the variables which will have values. and behavior is defined by the functions. That is how it would be. All about up in here. That is what we would go with this. The class diagram. Not only this, see, even when we are going with this class diagram up in here, this is the use case diagram. We look at this use case diagram. See, we have one use case diagram here. What is happening in this? Let's say this is your system. This is your student management system. Okay. So we can see this is the who part, which is basically actors. And this is the what part. So who's doing what? That's what use case diagram is all about. So in what part, what we have is these are the use cases. So student can check attendance, check timetable, check the test score. Student cannot update the attendance, student cannot update the score. Teacher can check the attendance, check the timetable, check the test score. Teacher can update the attendance and teacher can update the score. So how clearly it is, pretty small example, how clearly it is depicting that, okay, how this is all being done up in here. Then you have state machine diagram, which just talks about how different states your system would be and how onto those stages it will move between these stages depending upon the inputs. Like you'll enter the OTP, OTP will be validated. If the OTP validation is successful, then it will go with the user authentication. But if it is not successful, then it will ask you to enter the OTP again. It's like simple process. We have activity diagrams where you show different activities, like you'll open your email. If it is important, you'll read it. If it's a junk, you will delete it. So it's the like two different activities that we are showcasing here. We have a collaboration diagram, like how your application components are collaborating with each other. Let's say you have a login system. That login system is connected to an authentication system. So login system will go with the requesting the login with by filling in the login details. That would go to the authentication system, which would be requesting access from the database. Database will check the details and it will return the access that, okay, yes, it is a legitimate user. You can allow this particular user. So this is like your timing diagrams are like when you will be doing what. That is what timing diagrams are all about. You have component diagrams wherein you will, just put up different components. So there is a file, let's say your application file. So what it is made up of different components. So you have these three files, program files using which you have came up with this up in here. Then we have deployment diagram. Now deployment, when you talk about, see, what do we have in this deployment diagram here is deployment shows like how the application will be deployed. Okay, what are those? Deployment as in like delivering the application. So let's say it is an online video application, like we have YouTube, right? But it's like, opening your YouTube on your PC in a browser, then you're opening that. So it's a video player. Okay. Now that video player you'll open in your web browser in a PC. Now, because it is working with the internet, so that will, let's say, because the videos are not stored on your laptop, so it has to fetch those from somewhere online. So that request will go to a web server, which is again a device like a PC only, but it's a server where some file would be running, which will take that request. And data is still not there. Data is there in the database because generally your users are never allowed to access the database directly. No, because database has all that data. Data is always sensitive. So you don't allow direct access. It always goes via an authenticated server. So your request will go to the server. Server will request that data from the database to receive that data, and then it will generate that as a response, and it will send that response to you and your because browser knows how to make that response representable in front of you. And that's how it's all going to be. This is like a deployment diagram which shows the deployment team that okay, we need to set up 3 machines. One would be a database server, one would be a web server, and another one could be a user PC. Right? Onto database server, we'll be setting up the database. Onto web server, we'll put up a server side application. And user PC, there would be a browser installed. From that browser only, we'll be sending the request. So this is all about it. It actually works up in here with this. So this is like, few of those diagrams, those like we have in here in UML. You need not to know all of this because you'll not create all of these, but whatever some of these you will create, we will talk about those tomorrow. I will also make you learn the tool Microsoft Visio tomorrow. We'll learn that, okay, how you can use Visio to create diagrams like these, in fact, better diagrams with Microsoft Visio as a UML diagram creation tool. That is all we're going to see tomorrow in that. Okay. I believe this is all we have for the day today. Yes, do we have any questions? Yes, please.
It's not a question, Rajat. I just have a request if everybody agrees to it. I was hoping if we can just do 4-day sessions instead of 5. Like we don't do sessions on Fridays, if everybody is okay with it.
Yeah, that's okay. But what we can do is, if you're not able to join on Fridays, no problem. We can do some, some practices or some reviews on Fridays. That's not going to be an issue.
Okay. I mean, I can join. I was just hoping if like I have actually 3 kids and it's summer vacation for the kids
Understand.
in
No,
Texas.
no, that's completely all right. So what we can do is, see, we can't cancel the session, but it's okay. Understanding your scenario, what we can do is we can just, go with some reviews or some exercises on Fridays. That can be done.
Okay.
Right? So that you
Okay.
can just, view those recordings whenever you get some time, and it's not going to be something important that we'll discuss on that day.
Okay. I mean, I'll try to make it, but if not, then thank you for that.
Yeah, no problems, no problems. Right?
Okay. Thanks so much.
All right.
Bye.
Yep. Bye, folks. Have a great night and see you all tomorrow.